Okay, 7.3 volumes, and this is actually going to be part A. All right, so example 1, find volume if A equals 4 pi r squared. So I'm just a regular equation here, and I'm asking you to find the volume. Now, coincidentally enough, A is the area, and 4 pi r squared is the area of a sphere. Okay, this is the area of a sphere. Now, if I want to find the volume, I'm going to actually integrate the area. Volume is going to be the integral of area. So, volume is going to equal the integral of 4 pi r squared. And we are integrating with respect to r, which is the radius, right? For a circle or a sphere. So then, you know how I am. I like to take numbers and pull them out, right? So I'm going to pull out the 4 and the pi because they're just multiples anyway. They're scalars. They're only multiplying. They won't affect anything if I pull them out. So now I can integrate this peacefully, right? No problems. So 4 pi, and then the integral of r squared. So I add an exponent, divide by the new exponent. And I'm evaluating that. Oh, I don't have a limit, so I'm basically done, and then plus c. So let me clean this up a little. So let's see, the divided by 3 part, that could go with the 4. And then there's pi, and then there's r, and it's cubed, right? And then plus c. So now I integrated the area of a sphere, and I ended up with the volume of a sphere. This is the formula, except for the constant, which we can just assume is 0, is the volume of a sphere. Now, this relates to today's lesson because when we are asked to find volume on a coordinate grid or coordinate graph or coordinate plane, it's going to be 3D, right? So we're going to have to revolve it across lines like the x-axis or the y-axis. And the formulas to find these volumes is going to be pi, right? Times the integral from a to b of r of x squared dx. So, our volume is basically going to be our function squared, and our function is going to serve us as our radius. And that's going to get us the volume for the weirdest shapes that you've ever seen. So today we're going to mostly touch base on horizontal axis of revolution. We're going to go across the x-axis, which is the horizontal axis. I guess the next set of notes will tackle vertical axis of revolution, among some other topics. Now, notice how these are solids, right? And the idea is, with this, we're going to use the disk method. Basically, we're taking a funky shape and we're splitting it up into a bunch of cylinders. Skinny, long cylinders, but they're a bunch of cylinders. And that is going to approximate our volume. So example 2, find the volume of the solid formed by revolving the region bounded by the graph of f of x equals the square root of sine x and the x-axis. From 0 to pi about the x-axis. Okay, so whatever the square root of sine of x looks like. They want us to stay in between 0 and pi, so these are our limits. And now the formula for volume is pi times the integral from a to b of r of x squared. Now r of x is our equation, dx. So pi times the integral from 0 to pi of the square root of sine of x squared dx. Now I like doing this example first because you must be like, oh my god, if sine of x is u, what's du? That's cosine x. Well, there's no cosine x here, right? So I wouldn't be able to do this that way. But a square root and a square, right? This square root being squared, they basically cancel each other out. So I'm actually integrating to sine. So pi times, now the integral of sine is negative cosine, right? That's what I would have to derive to get positive sine. And then I'm evaluating from 0 to pi. So very quickly, unit circle, right? Here's pi, here's 0. Here the coordinates are 1, 0. Here the coordinates are negative 1, 0. So pi times negative cosine of pi minus negative cosine of 0. So pi times, now let's see, negative cosine of pi, this part right here, is negative cosine of pi is negative 1. Minus, over here, negative cosine of 0. Cosine of 0 is 1, so negative 1. So now I have pi, and then, ooh, negative 1 times negative 1. I mean, sorry, negative times negative 1 is positive 1. And then negative and a negative is another positive 1, so plus 1. So I have pi times 2. And my answer is 2 pi. That's the volume of the square root of sine x revolved around the x-axis. Okay, example 3. Example 3, instead of actually finding the area, what I want to do is I'm just going to analyze this function, and then you'll find the area later. Or, yeah, analyze the function. So find the volume of the solid obtained when the region in the first quadrant under the graph of y equals 4 minus x squared is revolved around the x-axis. Okay, you don't have limits. And in order to find the area or the volume, you need the limits. So analyze the function. Figure out what does this look like. So y equaling 4 minus x squared. Now this part here tells me that this is an upside down parabola. Oops. So it looks like this. This part here tells me that it is 4 units up from 0, 0, from the origin. So then, if I were going to make a rough sketch of this function, let's call that 4, it's going to look something like this. Now, they want us to stick to the first quadrant, so this right here. So our limits are going to be 0 to wherever that graph hits the x-axis. Let me do that. 0 and right here, wherever that hits. Now the easiest way to find that is to take the function 4 minus x squared and find the x-intercepts, or find the zeros. So 4 minus x squared equals 0. So 4 equals x squared. So x is plus or minus 2. So this is a positive 2. So our limits are from 0 to 2. and we're revolving that green part around the x-axis. So um, you'd be going around the x-axis. That's a horrible arrow. Let me make another one. Let's go this way. You'd be going around this way. Okay? You're turning about. And that shape is actually going to look like this. It's going to be like this. And then that's going to be circular. And let's call that the middle. So it's going to look like some kind of funky hemisphere. Alright, example 4. Evaluate the integral that gives the volume of the solid formed by revolving the region about the x-axis. Okay, so here's a picture of the graph. We are revolving it around the x-axis. That means that when I revolve, go in circles, right? This triangle shape is going to go, it's going to spin around and around, right? And when it spins, it's going to form this shape. It's going to look like a cone. And right here, this is the x-axis. And it's just going to spin, spin, spin. And if you spin a triangle fast enough, it just looks like a cone. So volume method is the same though. Pi, it's from 0 to positive 1. And then our function, negative x plus 1, you're squaring that, dx. Now this one you can use u substitution, or you can FOIL negative x plus 1. Just FOIL it. It's not that hard. Or you can use u substitution, whichever floats your boat. I think I'll do u substitution for this one, and then for the next one, I'll FOIL. So this is u. Right, so I'm going to write it here. So u is negative x plus 1. So du is negative 1 dx. So there is no negative here, so I'm going to compensate for that by dividing by negative 1 and then making that negative. So now I'm going to have negative pi, because I like bringing out negatives and numbers to the front. And I'm integrating, and now this is u squared du. And I'm going to go ahead and keep it all u. Keep it all about u. So you plug in the 1, and I get negative 1 plus 1, which is 0. And then you plug in the 0, and I get negative 0 plus 1, which is 1. So now my new limits are 0 and 1. So I'm going to integrate this, the negative pi, and then u squared becomes u cubed divided by 3. And then we're evaluating from 1 to 0. And yes, I know they're backwards. They're supposed to be backwards, because the 1 was originally on top, but when I plugged it in, I got 0. So it still stays on top. And then the 0, when I plug it in, I get 1, but the 0 was the lower limit, so its outcome is still the lower limit. Okay, so negative pi, plug in the 0, and I get 0 cubed divided by 3, so 0, minus, plug in the 1, and I get 1 over 3. So now I have negative pi times negative 1/3, which is a positive pi over 3. And that is the volume of this shape revolved around the x-axis. Okay, the try it should look familiar. It is example 3. But in example 3, we just analyzed the function, figured out where the intercepts would be, so that would be our limit. Figured out what the shape looked like, because you need to be able to do that if you don't have a graph, or if you're not able to use a calculator. But anyway, so here's the graph in the first quadrant, and if you spin this, right, across the x-axis, you spin it, you're going to have the flat side, and then this is going to look like that, and then that's going to look like that. It's not quite a cone, not quite a circle, or a hemisphere, right? But it kind of looks like a hemisphere. And then here would be the x-axis. And so you're finding the volume of that shape. So volume is pi from 0 to 2, right? But we had figured that out in example 3. And then 4 minus x squared, right? Because it's r squared. So 4 minus x squared is the r part. So squared, and then dx. So now this one, if you try to do, um, u substitution, the derivative of 4 minus x squared is negative 2x. There is no negative 2x anywhere there, so you can't do u substitution. At least, well, you could, but you don't have to. So what we're going to do is we're just simply going to FOIL. FOIL the 4 minus x squared. 4 minus x squared times 4 minus x squared. So we're going to FOIL that. So what we're actually going to integrate from 0 to 2 is 16 minus 4, or sorry, I'm just going to go ahead and do the whole thing. Minus 8x squared plus the, oh, I can't think. Negative x squared times negative x squared, which is positive x to the 4th. Okay, yeah, that's good. And then dx. Okay, not really difficult to FOIL a square, right? Like if it's to the 5th power, we don't want to do that, but they wouldn't give you that either. So pi, and then integrate. So I get 16x, and then I get negative 8x cubed divided by 3, and then plus, and then x to the 5th divided by 5. And we're evaluating that from 0 to 2. So plug in the 2. And notice how the pi is still there. Please don't forget the pi. So we're plugging in the 2. So 16 times 2, that's 32. And then plug in the 2 there. So 2 cubed is 8. 8 times 8 is 64. And then 2 to the 5th is 32 over 5. And then plug in the 0. I get 0 minus 0 plus 0. So that's irrelevant. All right, common denominators, just in case we can't use a calculator. So the least common denominator is 15. So 32 times 15 is 480 over 15. Minus 64 times 5 is 320 over 15. And 32 divided by 5 times 3, to make it the denominator 15, is 96 over 15. So then I have pi. And then simplify that, and there's 256 over 15, and that's my answer. That's the volume. 256 over 15 pi. And that's the volume of this region. All right, and that's it. Finish any assignments you haven't done. We're going to review next class. There's a test on, what's the last day? I see you Mondays, Tuesdays, so Wednesday. There's a test on Wednesday.